All right, here we are in just in time a presentation mode. What we're going to do today is have a quick look at an open source project that's a product from within the Dell EMC community. It's not a product that we sell in any shape or form, but it is one that we utilise within ourselves. This is effectively a tool that is our bare metal control plane. This is part of the offerings from our community onboarding program called the Code by Dell EMC. What is Code by Dell EMC? All open source projects that are driven from these organisations, and we're normally an organisation that you associate with open source, are all contained in that one place. Not only is it a Git repository, but also all the associated community points so that you can collaborate with the actual the greater community and the developers directly within this. So where you think normally you'd be talking to via email to your colleagues in the workplace, in this case you talk to Slack, and you're able to talk not only with and also share ideas and also have products that are driven by the community. Most products are all focused around automation and bridging those sort of gaps within the new sort of to utilise an overutilised term, cloud native style architectures. So all good. Code by Dell EMC. Just do that as a search, and you'll see all sorts of cool tools. So what we're talking about here is a product called RackHD. What's RackHD? Well, it's all great about the cloud and all that sort of stuff, and we consume on that, and we build our workloads upon that. But the reality is that when you're doing that, you're abstracted away from the physical heat generating componentry that's underneath. It still exists, it's just that you don't care when you're out into the public cloud. You bring that inside your tent, you all of a sudden need to care about the physical side. So how do you get that sort of responsiveness, that ability to consume services, but have that so not only is it about the that sort of abstracted view, so whether it's into vSphere, your hypervisor layer, how do you get that to translate down to the physical layer? How do you start consuming to utilise the term infrastructure as code? How does that really, we hear that a lot about Puppet, we hear it a lot about Chef, but and Salt and Ansible and all these other configuration tools, but they look at it at a different layer. They're talking SSH, WBM, so they're grabbing into those machines, or they're using agent-based control and communication between those devices. The gap is you want to go lower level. Start looking at what is the physical componentry. How do you look after firmware? How do you look after the existing power state? How do you turn on a piece of tin and then have that tin actually get ready for operation in a hands-off templated methodology? So nice to use Puppet and all those tools up above, keeps everything, stops configuration drift, keeps everything aligned to a standard. You're abstracted from the caring where the physical componentry is, because the same tool's over the top. But when you're on premise, you also need to have something. That's what RackHD is all about. But it's also beyond that as well. It is a workflow engine around that. It also does a telemetry data, pulls all that information in, lets you feed that into a northbound service. And it does it in an open architecture, so it doesn't really care what the pieces are underneath. If you've got, if you're about building a Linux device, or you're building a Windows device, or if you're about putting a configuration or updating the firmware in a Cisco Nexus switch or an Arista switch, maybe you're looking at power draw figures out of a PDE. This has all that ability. It doesn't talk at the languages that we're used to. It talks at a lower from a direct interaction to an OS. It talks at that lower level, and does it all in a very API centric methodology. So, and it does that through a bunch of tools. It's a bunch of modules within this. Everything's written in Node.js. So if you know JavaScript, you can very easily walk through the code and the logic around this. The architecture around it, and Monorail is the term for the engine room around this. Monorail is nothing to do with The Simpsons. What it actually is just, that was the name of the cafe where the guys were sort of storming around to come up with the idea. So hence that's called Monorail. There's a bunch of components in there. You've got on HTTP, so that gives the RESTful interaction into that, gives a user interface. You've got the web services, the WSS services. That's so you've got a nice user interface. Task graph, so that's the workflow engine within that. TFTP, because if we think from compute, how do you interact with a piece of tin that's never been turned on before? You've got to get it into a PXE-based environment and put a bootstrap in there with something that allows you to start kicking off communication into that. And thanks, Jeff. And then you got DHCP, so it can either act as a DHCP prime, so use an ISC DHCP, or can act as a proxy. It needs to be able to do that because based on what it knows about a device, it will dynamically change the scopes that are options associated to that device. So it might boot it into a discovery state, might actually try to boot it into a install launch, etc., etc. And syslog, it uses, we've got elk under the covers here as well. So you've got a log aggregator so you can pass it on. For database state, you obviously got MongoDB, gives us the stateful retention of the information and the data that it collects and the context that you give it. I've mentioned DHCP, and obviously RabbitMQ provides AMQP-based interaction. So that's our message bus service around that. And you can also interact directly into this from above. So what's it do? You think about this, if I walk through a typical device, a device gets, you get a piece of compute, doesn't matter what that piece of compute is, and I'm homing on compute, but as I mentioned before, all sorts of devices are supported. You rack it up, you power the thing on, first thing it does is it goes, well, I've got no image, I've got no nothing, I'm just going into a discovery state, into a new state. This thing goes, hey, I see you, hey, I don't know you, I'm going to go into a discovery state, and we'll boot into a bootstrap, start polling as much information as it can off that device. Or you can do it through an SNMP. So in a switch, it'll talk SNMP to it and other devices. Or you can just manually add devices in, because maybe you've got a data center with a bunch of devices already in. You don't necessarily want this to take control from the get-go. So you can do manual entry so it can start looking after those devices as it is. From there, it does a skew discovery. So it pulls all this data in. So you can then do pattern matching against that data that it collects and then associate a workflow into that. That workflow, as we call it, is a graph. A graph can be anything, could be something to change the boot order, change the power state, talk IPMI into it to change the boot order. It could be do a SNMP query against it to get a particular action against it. Could be to execute a install routine. In that. And then at the end of it, because you want to keep track of what's going on with the device, it will create pollers to keep interacting with that device. So it'll do defined, frequent-based measures back. Because you might want to say, actually, everything that's in there of this firmware revision, we need to bring the firmware up. And we know that we can do that with a lot of opinionated tools that are direct from the vendors, but in this case, this one is open in that sense. So it doesn't, you get all that joy, but with a open framework. It doesn't matter whether you've got a mixed environment of devices, this will look after that, but allow you to consume it and define it as templates, so you've got a standardized approach. The portfolio keeps on growing what it supports. And as I said, think of everything in rack. This thing is, we eat our own dog food, so we utilize this ourselves with our own converged infrastructure play to do the bare metal control underneath that. So everything in rack in this is able to be controlled with a view that it'll palm off to a northbound service for that ongoing operational state control. Again, this will keep polling via SNMP, IPMI, Redfish, whatever way it is. It'll keep polling into those devices to get the details so that you can continue to control and the state of that physical side, but expect to be passing up to some northbound service to look after the operational, the service state of those machines. Beautiful. All right, Alistair, how much time have I got, buddy? Plenty of time. That's not what I wanted to hear. I wanted to hear you say that it's all tight. All right, the demo is a little bit lax in this because Alistair won't let me get onto my own environment. The UI here is this is not a user interface-centric device. This is an API-centric device. So the UI is a follow-on. So you can drive it through the user interface, But really the case is that you'll use either the CLI-based tools or you'll use the RESTful API. And again, if you're familiar with RESTful APIs, you're probably familiar with the self-documenting mechanism of Swagger into that. So again, within here, you can very easily test out the APIs that are associated within this via Swagger. We've also got a bunch of CLI libraries in it. You've got Java, you've got Go, you've got JavaScript, all these sort of things. So you can use those tools that you know and you're familiar with. Each device that comes in is categorized as a node. It doesn't matter whether that node, if I turn on a blade, for instance, it'll have a look at the blade. It'll also, as it does a crawl, discover that it is a blade, and it'll then talk to the enclosure, the chassis around that. So it'll bring that in and also treat that as a node. A switch is a node. A power is a node. A rack management system is a node. So it does that, pulls the information in, and it does that. Each node has a series of catalog items, so catalog categories into that. So that could be, if we think physical side, it'll talk about the memory, it'll talk about the MAC address details, the NICs that are in there. It'll pull back the serial number, all sorts of context around that. And you can do, oh, wait a sec, sorry. Apparently I've got to be somewhere else, Alistair, reminded me. I don't even have Outlook running. So going on with that. So once you pull that information in, what you can then do is we have as mentioned before, a SKU. A SKU then looks at the information that's pulled out, and you can see here I'm looking at DMI information. In this context, I'm looking for a virtual machine from VirtualBox that's got 4 gig of RAM. And within that, I am then going to execute a graph that is install ESX. If I have a look at a graph, I can go here, install ESX. You can see that a graph is really just a set of instructions that are associated to predefined tasks within that. A predefined task may be install ESX, but it's not just straightforward as install ESX. ESX, you boot into the first state, you then go into the first boot order and the second boot order, everything to get a configuration context, because at the start all you can do is change a password, set a master IP. You really got to get into that second boot and start doing logic within there to tickle it a lot further. Go a step further, you also want to give a IP address details. Start to configure that, the networking, the storage, all those, maybe enable SSH, maybe it's, and I'm talking here ESX, but it doesn't really matter what that OS is. You, again, talk to this through JSON files. That allows you to sort of define the context of this as code. You can make it as simple or as complex as you want. If I have a look at a task, for instance, ESX within here, so a workflow, again, a graph is a workflow, so it's a bunch of logic that will have pre-events, and events will execute based on the success criteria of the prior task. If I have a look at a task, in this case, you can see all the options that I can start to feed through into there. It's and that inherits also tasks from OS. So an OS would have all the networking details within there. So I can customize as far as I need to into that. The way that works is if I go back over here, we've got the SKUs to push it off. To that, we've got the graphs that go into that. The first thing it does, it will pull a profile off. A profile will boot into what the environment, the control environment within that. So example of that in a ESX world, it will bootstrap into the ESXi installer. So I define where those files reside. Do they reside in a TFTP or a HTTP repository? Am I doing a core OS or doing something like that? You can see quite a extensive view into the support levels. From there, you're starting to look at your templates. What are your templates? Your templates are things such as, we think in the Windows world, it's an unattended text.file. It's within the ESX world, it's Kickstart. Within Cisco Nexus world, it could be a startup config. Again, you got all these. It could be a Python script, could be a PowerShell script. You can see there's quite a number of various. And just to home in on that, you can see that there's PowerShell scripts, Python scripts. Those scripts, the idea is that they get pulled down to those remote devices. That's part of your logic. It'll pull it down and execute those on the local devices, as well as handshake back and forth. It uses Ansible as a configuration tool of choice to allow that interaction going back and forth. Very cool, very straightforward. If I have a look at this, the nice thing about it is you feed these options through, as you would expect with infrastructure as code, everything's an environment variable fed into that. So you define those variables up front. It'll inherit a bunch of globals and master settings within that. You can then reference that as you reference those. Those values are passed all the way through the logic as they go. Globals may be things that it knows, such as the networking information or the environmental or the control plane. Or alternatively, it could be just details that you feed through. You also, because you may have custom requirements as part of that routine, you can just push files straight into the device as part of your graph and pull those off as you require. Very good, very straightforward. This thing is as said before, it is open source. It is written in Node.js. There's also the tools and the associated libraries that are written in Go and Java, etc., etc. So you got your very easy to do the walkthroughs on this. Now, if I go back into here, again, you want to have a play with this. It's not a complex installation routine. Very well documented within Git. You can use a it's up to you. It's Ubuntu, CentOS, whatever Linux flavor of choice that you want to utilize. If you want to play with it within your own laptop confines, so utilizing VirtualBox. So that's all it needs is Vagrant and VirtualBox and Git, of course, because you've got to do a Git clone down into that. You can get this up and running and muck around with it within a laptop. You can do it with 8 gig. 4 gig of RAM, really. You can be up and running. Very small footprint around that. Very cool tool. There's also, just so you're aware, there's plugin supports around this. So a good use case where the plugins go, think of a Kubernetes. So we have Kubernetes when you're starting to talk about your nodes within Kubernetes. We have a node plugin for this so that you can actually reference RackHD for a node UID, and it'll dynamically create that node on the fly for you. Another example of that is Docker machine. So you want to create a Docker swarm, for instance. You can pass or a Docker runtime machine. You can use Docker machine and use the RackHD plugin for Docker machine to directly create your Docker machine, Docker nodes on the fly. A nice, easy way to bring control, because we think things like Docker machine, Kubernetes, they're expecting, in a test harness sort of situation. They're very generic. They tend to be stateless as well. So this is a way to bring a stateful control, a templated way to bring it into your operating system environment while still leveraging those sandbox style tools. I mean, very cool, nice and easy. I didn't really have to take much time as it was. A demo on the fly. Cool. Thank you very much.